So today we will talk about the last segment in the fake news detection part of the course. And today's paper is about propagation-based method. Okay, so if you recall, we talked about knowledge-based methods, we talked about style-based methods, and we also said that we'll talk a little bit about the propagation-based methods. So this is one of the papers of my liking, because you will see that there is a lot of interesting like graph structures and graph ideas that are being used in this paper. And this makes the paper, and like how certain graph signatures can be used in order to detect or solve a very hard problem like false rumor detection. Okay, so that is why it makes the paper very interesting. So the title of the paper is False Rumors Detection on Sina Weibo by propagation structures. This was by Kiwu, Songyang, and Kenizu. So this paper actually tries to leverage the propagation structure of messages to identify false rumors. So note that in general, identification of false rumors is a notoriously hard problem. Why? I'll tell you. Let us say we have two messages. Okay, we have two messages at our disposal. So one is given by, so this message, both these messages or both these you can say short news reportings. So I guess all of you know what is Sina Weibo. What is it?
A Chinese platform similar to Twitter.
Yeah, a Chinese platform. Okay, and what was the original like reason for the like for the inception of platforms like Twitter and Sina Weibo? What was their main original purpose?
Share news faster, like as it
Share,
happens.
share news in the form of, anybody knows? That's why they are called
Microblog.
microblogs. Very good. Micro because very short messages, news messages. Okay, so That was the original like requirement for the inception of these kind of platforms. Okay, so now let us take the example of these two news outlets on Sina Weibo. They are talking about a case that is caused by something called a rove beetle. Okay, so they are reporting a case by rove beetle. Okay, so let us say that the first one is, the news outlet's name is and the news that they forecast is the following. So this is a news piece on one side, released by one of the news media outlets. There is another news media outlet on the other side by the name I am writing this whole thing for a reason. So I hope you were reading like the text messages that were posted by both of these um, news agencies or news outlets. Now, tell me, like, what is your best guess as to which one is false news and which one is a true news, or a potentially false news and a potentially true news? Which one do you think is a potentially false news?
The dirty cat eats foul fish or
The
something.
dirty cat eats foul fish. Okay, so why do you think that it is? Uh,
Like, it
mm,
starts with please repost, like they are more interested in just spreading that. Also, like
okay.
the information, like in the first one, it does some concession, like yeah, it won't kill you, but it can cause damage. Like it doesn't bite you, sorry. But this
Mm,
one is like more fear mongering, it seems.
mm. Okay, so now think about a computer or let's say we have a style or language based classifier. Okay, what is the problem if we have this kind of a system to classify the above two pieces of text? I mean, for humans, it's easy to read and like extract certain uh, deep semantic signals, but uh, for an for an ML algorithm, like which is driven by, say, the linguistic signals, the kind of signals that we studied in the previous paper, it becomes like increasingly more difficult. Can you tell why? I mean, some hints as to why. Because all these style or language based models, if you remember, depend on presence or absence of keywords. So basically, it is finding certain keywords or searching for certain keywords. Even the very, like, very advanced sophisticated DL models, like that do regular NLP tasks, for instance, the transformer based models, even they actually, if you look at, like, if you try to explain their performance, you will see that in many cases their major performance relies on the keywords present in the text. Okay, so most of the clues are picked up from the keywords and the context around the keywords. So somehow the system understands that these are the keywords and I have to look for the context around these keywords in order to make a classification. But here, the problem is that for both the um, real and the fake uh, news item, the keywords are very similar if you look carefully. And this is one pathological example. It could be even more difficult. So difficult that even a human judgment is not possible. Okay, so say for instance, in both uh, in both the news piece, you will find keywords like crush, venom, doctor, skin. So all the important keywords are present in both of them. Okay, so these are like the hero, rove beetle. Okay, so all of these keywords are present in both of these news pieces. So it becomes very difficult to identify which is which, okay, using simple linguistic signals. So what do people do? So these people try to identify the uh, identify additional signals from the propagation structure of the news. So what is the propagation structure? So if you have used Twitter, I guess most of you in this class have a Twitter profile. So if you have used Twitter, you might recall that you can reshare the message. Okay, you can reshare the message, and in the reshare you can also mention. So this is better known as, in the Twitter world, this is known as retweeting. So this retweets, if you look at the chain of retweets, one can construct a tree-like structure. We will talk about this in more details. So one can construct like a tree-like structure which shows the propagation path the retweet or the propagation path of the posted message. Now the authors went in to hunt this propagation path or the propagation tree. Okay, so this propagation tree is what the authors tried to hunt and see, like, if there are not much linguistic signals, whether these kind of tree structures could give them some idea to delineate between a fake news or a false rumor and a normal news. Okay, so in order to do this, like, what they like came up with is the concept of categorizing users so I'm telling you the overview first, and then we will go into the important details. Categorizing users into opinion leaders and normal users. So we will formally define who is an opinion leader, but for the time being, as the name suggests, think of these to be very influential users. Suppose by some computational method, you are able to identify the very influential users in the propagation structure. And the normal users are the users who are not opinion leaders. Okay, now based on this classification, I'll show you an interesting picture of the, or an interesting propagation structure of the two news items that we just now saw. Can you see the two pictures, all of you? Can you tell me please if you are able to see it?
Yes, sir.
Okay, fine. So the first one is the false news, the false rumor. And the second one is the true message, as you have already voted it to be. Okay, so now for the time being, like we have not defined who are opinion leaders. For the time being, those accounts which have a V beside them, let us call those as opinion leaders roughly. Okay, so those I am marking as O, let us call them opinion leaders. Okay,
Are they verified accounts like on
yeah,
Twitter?
kind of verified accounts, but we will have a more concrete and formal mathematical definition. These are verified accounts. I mean, that's why I said that for the time being, let us call them opinion leaders. It's not like hard and fast. We will put an additional constraint on the verified accounts, but for the time being, let us assume that these are the opinion leaders. So now, if we call these people as the opinion leaders, can you tell me whether the two propagation trees show you something different in them? So you see, like when you have to do a research, you have to really be very investigative. They did not have any clue in the beginning. They thought that they had a hunch that the propagation trees might be different. So they took these two propagation trees in front of their eyes and started looking at them and wanted to see like if there is any shallow signal. So as I told you, most of these signals are very shallow signals. If there is any shallow signal that is coming up from this propagation structure. And indeed, there seems to be some shallow signal that is being reflected. Can you identify what is that?
There are longer chains of like
No.
influential
So
accounts.
let me guide you a little bit. See, there is a reason why I suddenly defined opinion leaders. Think from that point of view. That has some bearing with this identification. Okay,
The
one more
source
thing.
is not an opinion leader, but the sharing people are.
Very good. Excellent. So you see that in the false rumor, the propagation tree is something like this. If I abstract out and draw it, so there is a normal user who is first. So for this particular case, there is a normal user who is starting to propagate the news, and suddenly one or two opinion leaders somehow gets confused and start propagating these in their channels. Okay, so this is the curious structure of the propagation tree for the false rumors. Whereas for the true messages, the structure is slightly different. It is typically initiated by an opinion leader and then picked up by a lot of normal users. Agreed? So that is what is coming out. So this is one of the interesting like uh, observations on which this whole paper is based. Okay, so usually a false rumor starts from a normal user and is picked up fortunately or somehow by some opinion leaders, and then it gets like a lot of publicity. Whereas on the other side, the true news is usually initiated by a authentic source or an opinion leader, and then it is taken up by a lot of normal users. Now I will make the screen a little larger for you to view the first propagation tree corresponding to the false rumor a little bit more carefully. Do you see anything else apart from this signal that I have already shown? Is there anything else? Now you
The
will have to
follower
do
counts for the original account.
little bit more deeper thinking. I'll give you a hint. So uh, now look into the nodes themselves, the users themselves. You have looked into the tree. Now go into the nodes and see if you can discover something in the nodes, inside the
I've,
nodes.
I've
Secondary
heard this
repost.
before or something like that.
Haha.
I've heard this before, I've seen this before, something statements like this are written.
Yes. So basically, what is that? See, some of the normal users are actually refuting or disagreeing to this message, and this becomes an additional signal for the authors. So basically, the authors take these clues as additional node attributes. You see, some of the normal users are pointing to facts. That's, if I make it a little bigger, this is a false rumor. Someone please refute this rumor. Okay, so already certain people in the population of users are aware that this is not a true news, and therefore they are trying to raise an opposite pressure. Okay, so there is a disagreement with the original news being like reshared. So this is an additional clue that the authors will be using in the entire formulation of the problem. Okay, so I guess we have got some motivation. Now let's get back to our note diary. Okay, so now just like Twitter, Sinawibu also has the follower-followee system. So for the sake of completeness, let us define what are each of these. So user can follow other users. Okay, so these are the friends of that user. Okay. And users can be followed by other users. These are the followers of that. Okay, so a follower receives a message posted by his her friends. Okay, and they can respond to these messages by reposting them. Very similar to the Twitter structure. Okay, now the authors will define something called a message propagation tree. So a forest W of message propagation trees. So each tree T is a V, okay, where V represents nodes, okay, corresponding to a text message posted on okay. Now this message is 140 characters length and each message we denote by M, and this M also has additional metadata which are U, T, C and I, where U is the creator of the message, T is the timestamp of the posting of the message, okay. C is the device from which the message has been posted, and I is image, etc., if it is present, okay, in the message. So now you can define the message propagation tree edges. So these are the nodes. Now you can define the message propagation tree edges as follows. Okay, if there is a directed edge from M1 to M2, then M2 is a response to M1. So you read it as this. So if there is a directed edge from M1 to M2, then M2 is a response of or a response to M1. And the user U in addition also has its own metadata like the gender, the number of friends, followers, number of messages posted so far, time of last post, etc. Okay. So typically, suppose you have a message structure or message and message response structure like the following: M1, M2 is a response by user 2 to user 1. With its own share of message added. M3 by user 3 is again a response to user 1. M4 by user 4 is a response to user 2. Similarly, M5 by say user 5 is a response to user 2. So in this case, you can draw the propagation tree as follows. M1 is the root message. There are directed edges from M1 to M3 because M2 has responded to M1 and M3 has responded to M1, and two directed edges from M2 to M4 and M5 because M4 and M5 have responded to M2. So this is the corresponding propagation tree. Okay, so in the task of the false rumor detection, the authors are interested to identify the truth or falsity of only the root message of the propagation tree, not any other messages. Okay, so basically, given the tree, so their problem is given this and all the metadata that we talked about, okay, decide whether root T is true or false. This is their task. Okay. So now, in order to further formalize the propagation tree, building of the propagation tree, we will define quantitatively the opinion leaders first. So if you remember, every user in the propagation tree has as a metadata along with it the number of friends and the number of followers. Okay? So the opinion leaders are those for which the number of followers as a fraction of the number of friends is greater than some value alpha. Okay, of course. So alpha is greater than 1. Okay, we want alpha to be greater than 1. They will set their hyperparameters later. We will see like what hyperparameter works best for alpha. They will set it using a validation set. Okay, and number of followers should be greater than or equal to 1,000, because like somebody can have like one or say 2 followers and 1 friend. This will give you an alpha which is admissible because alpha has to be greater than 1. Okay, but we do not want this kind of situations. These are not opinion leaders. So therefore we keep a bound on the number of followers. So the number of followers need to be above 1,000. Okay, so now they also label the ages. So this is how the nodes will be labeled now. So nodes will be either opinion leaders, which they will call P, and normal users, which they will call N. Okay, so nodes can be either P or N. Now similarly, the ages need to be labeled. So how do we label the ages? So if you recall that there was this idea of dismissal of the rumors. Some of the users were dismissing or disputing the uh, original message. Okay, so if we could capture this and place on the edges, that would be helpful and enrich the propagation tree. Okay, so every edge, say mi to mj, okay, is represented by a triple. Let's call it dj, where A is the approval score of mj, okay, which indicates the agreement of mj with the root message. Okay, similarly, D is the dispute score of mj, and S is the overall sentiment of mj. So these are the 3 things. So later on, when we will discuss about the experimental setup, we will see how to compute each of these from the messages mj. Okay, we will see how do we compute this. So for the time being, let us assume that these are given to us. For the mathematical formulation, let us assume that they are given to us. Okay, and theta is a damping function.
So why is there a separate approval and dispute score?
Yeah, we will see like why is there a separate, actually this is x and this is kind of 1 minus x. We will see why the authors kept both. Let us delay this or defer this up to the point where we discuss the the experimental setup for computing each of these. Let's defer this. Like in the next class when we study, we will I'll try to cite the reason why they use this. Okay, so theta is a damping function which looks like where t is the time difference in days between the post of the original message and post of mj and post of mj. Okay, and rho is the damping factor between 0 and 1. So what does this say? We will stop here. What does this say? Why this damping factor in place?
The higher the time difference, the less effect it will have.
Yeah, so basically the hypothesis that the authors have here is the following, that the sooner the response is, the more intense it would be. So if some message is being reposted after 1 month or like say 2 months, that does not like account much. Okay, so that's the idea. So it has to be like taken up fast, and if it is taken up fast, then it is like more intense. Okay, that counts more in the authenticity, in identifying the authenticity. So therefore now you can have the all those m1 m2 can be removed, and you can just have p's and n's in your tree, and each of them can have its own edge features, etc. Okay, so this is how the tree will look like. So next day we will see how this tree is post processed and how signals are extracted from this tree.
I have a question about the like damping hypothesis. Like, isn't it easier to agree with someone? So, like, aren't people more likely to agree sooner rather than dispute? Like, disputing would require some research, and it might take a bit longer to respond if you want to dispute.
Um, True, true, very true. So, here the assumption is that somebody who is disputing fast has already seen this message somewhere else. Okay, so they are very proactive on the platform, and so typically someone who is going to dispute it fast would be, what do you think? Would be a opinion leader or a normal user?
More likely to be a leader
If it is
as
this, yes. So that is what is the assumption that they're having. So if it is a leader, then typically I mean, the outlet will dispute the news very fast. Okay, but for normal users, what you say is very valid, that it might take some time for the dispute, and therefore dampening the dispute in that way might not be very effective. But like, you have to somehow come to a middle ground. Okay, so that was what the authors found to be a middle ground. Okay, so they did not want to have like one as an increasing function and the other as a decreasing function. So that they did not want to have. So that's why they just like um, kind of uh, went for a single kind of a damping function.
Yes,
In
got
fact,
it.
it's a good idea. Like you can see, like if you have an increasing damping function, then how do the results get affected? As I said, so these are like, experimental things. You have to really look into the results and see if that affects.
So, also, I have one more question. Like, Twitter also has a feature called quote tweet, and quote tweets are like commonly used to dispute with a tweet. So maybe like the platform Weibo doesn't have. I'm not sure. So
Yeah, the Weibo doesn't have. Exactly, very nice point. So these code tweets can also be used. The code tweets, in fact, we were doing some work where we were trying to, do stance detection, where these kind of code tweets could be useful in order to do the stance detection. But the unfortunate part is that, uh, say, out of 10,000 propagation trees, only for 50 propagation trees you will get such code tweets. So actually the signal is so shallow that it's very difficult to extract anything from there.
yes, sir. Got it.
Okay, so I'm very happy that we had this interaction today. Okay, so we'll stop here. Most probably tomorrow we will have the rescheduled lecture. If everything goes well, we will have the rescheduled lecture of Kiran. I will uh, double confirm with him and then only inform you. So that's why I do not want to say anything like beforehand. I'll double confirm it with him, and most probably tomorrow's lecture will be by Kiran, and next week we will continue with this uh, paper.